Okay, so if the whole recipe is 51 ounces, we want to talk about what will go in each of these parts for our bar. There are only, again, 2 ingredients, 3 cans of vegetable broth, 9 ounces of tomato juice. Why do you think that that thing was split up into 4 parts? Why did we split the bar, in this case, into 4 parts? Riley? Yeah, and I'm going to come out here to the right, and I'm just going to put 9 ounces out here because that's part of the recipe. The other one, like Riley said, is 3 cans of the vegetable broth. Now, I don't know how much is in each can. That's what I'm trying to find out. So if I don't know how much is in it or how much the value is, what do I do mathematically in that place? If I don't know how much it is, Lana? Well, how about before we get to that, what would I put in, if I wanted to fill this bar in, what would I put in those places? Yeah, some variable, right? I don't know what these are, so maybe X, and that's going to represent maybe ounces per can. I don't know. But I know I have 3 of these. Can 1, can 2, can 3. So there's your bar. 3x plus a 9 is going to equal 51. That's what the equation would look like. And this is called a 2-step equation. Why don't you figure out what x equals? I'll let you try it first. Try to give me the value of x that's going to make that bar equivalent to 51 ounces. Yeah, good. If you're stuck, let's start talking. Some of us have the answer. I saw it in a couple rounds. Some of us, I think, we're just doing the final calculations on it. But if I wanted to figure out just the broth, how much is in each can, what could I do? Tell me how to kind of take this bar apart and make sense of it. Natalie, go ahead. So the whole recipe is 51. You're saying take away the tomato juice from that? All right, so if I took away this 9, 42. Good. So 42 divided by 3. Do you get a value? 14. So 14 ounces. Okay. Good. I like it. Yeah, it is 14 ounces. So going back and doing what Natalie just told us, she took away the 9 ounces, and if I just modeled this, this 51 becomes 42. And now that bar only goes from here to here. So 3 x's are equivalent to 42 ounces. Well, if you broke those up into 3 equal parts, it's just a division problem. But look at our equation. It started out here, and then after she took 9 away, it became 3x equals, not 9, 42. Okay, so then that's the 1-step equation. This is what we were working on last week. You would just say, well, you would divide both sides by 3 in this case, and you would get 14. But the bar is just showing that, okay, this whole amount became 42. We break that up into 3 equal parts. Okay, let's try underneath there. There's 3 of them for us to try. Let's do the first one together because this one now doesn't have any context to it. It's not like a cooking problem. It's just an equation. 4x plus 5 equals 17. Here's the rule of thumb. The bar is always equivalent to the overall isolated term's value, which means 17 here. This term out here is equivalent to the length of this bar. So if you want to put 17 down here, just to keep track of everything, I agree. That means that this top bar is equivalent to 4x plus 5. So how many parts could I break that up into? If you're not sure, that's okay. This is really our first try at this. How many parts do you think, Cameron? 5 parts. Why 5, Cameron? Yeah, so let's go 1, 2, 3, 4, 5. She said we're going to need 4 x's, and then you're going to need a 5. So that 4x plus 5 is equivalent to 17. You're like a ninja, Maddie. You just slipped in. I didn't even see it. You were here or not here, and then I turn around and boom, she's there. So what do we do to try to find this value of x then? Without just guessing at it, I have people be like, I tried 1, that didn't work. I tried 2, that didn't work. I kept going. We don't need to do it that way. Jonas, what are you thinking? Okay, so you're going to take 5 away from 17, and you get 12. So if I remove like this amount right here, then that means that this amount from here to here, slowly, is now equal to 12. So if I rewrote this up here, you have 12. Yeah, another way to look at it is as a division problem. So I could divide 12 by what? 4 into 4 equal parts. And that must mean that every part is equal to 3. So the bar is demonstrating that. It's like we removed, this part went away, and we took away the equivalent amount of the 17. So we're left with just this 12. Break that up into 4 equal parts. Y equals 3, or x equals 3. All right, go ahead and try the next 2 on your own for me. Try to do it with the bar. Remember, tonight I'm going to ask you to use bar diagrams, so I want you to kind of understand it. So humor me today and try to do it with the bar. Okay, we're in the notes. It is correct, yeah. Did you get that? Yeah, good. Try that one. Did you get those? Or check that one though, because if I do 6s, 6, 12, 18, 24, 30, 36 plus 5. So you got a different number on that one. Yeah, that's good. That's 4. Good. And then you're still working on that one there? All right, go ahead. Mm-hmm. No, you would. One of the parts would be this constant value of 2. but the other parts would be broken up into 5 equal values of y. So you have 5 y's, and you have a 2. So that would be actually 6 total parts, right? Because you have your 5 y's, and then just the individual 2. Like up here, we did 4 x's, and then a 5. So that's why we broke it into 5 parts there. Okay? Yeah, no, that was right. Excuse me. You get it, Jack? So good. Yeah, yep, good. Got it. Yeah, Lauren, those look good. Okay. I can check it from here. Uh-huh. Yep, good. Yeah, that looks good now. And then that was 3. Yep. Okay. So what we're doing here is we're taking, like on this one, we're going to break this bar up into 5 y's. You're going to do like y, 5 times. And then another part of the bar is just going to be a 2. You would just write a 2 in that bar. The whole length of the bar is equal to this 22 value, okay? And then that's where I'm going to pick up here, and I'm going to start going over it, and you can kind of follow me on this one. So tell me about this number 2. How many parts did you divide your bar up into on number 2? Just the total parts. I don't need to know the value of each or anything like that yet. Just total parts. Go ahead, Lauren. 6 parts. Okay, so if I go 1, 2, 3, 4, 5, and 6. Now, what goes in each part there, Lauren? So I have 5 y's plus a 2, and that's going to equal, the whole thing is 22, right? So I saw some people just putting out there equals 22. That's fine with me. If you want to put it beneath it, that works too. All right, so then how are we going to break this down to get the value of y? What would you do first, Jack?
So what did I took 22 minus 2, which is already like known.
Uh-huh.
And then I did 22 or 20 divided by 5, which is 4.
So when you take the 2 away, like I did right here, this amount that's remaining, just modeling it, is now going to only equal 20 instead of the 22. We just like imagine taking scissors and cutting that end off. Two are gone. So I know 5 equal parts are equal to 20. So then you'd figure out, well, what's the value of 1y? Well, you divide it by 5, just like we've been doing, and that's how we end up with a value of 4. Go ahead, Jack. Yeah. So, oh, how many lines? Okay, yeah. So you're saying like 5y, I'm going to break it into 5 lines, which means it's going to create 6 parts. All right, so then on this one, you're going to do how many? 6 lines? So 1, 2, 3, 4, 5, 6. So then 6 of the values or 6 of the boxes are P. And then you have a 5. Good. So we take a 5 away, and then we're left with 18. So this whole part here now, from here to here, has a value of 18. So 6P equals 18 now. Okay? So then what's your final step? Divide them by 6, yeah. So that means every value of this variable would be 3. And you can check it if you want to plug them in there. You just do 6 times 3 is 18. 18 plus 5 is 23. If that works out, then that's good. Okay? So I'm going to show you a slightly different way, because tonight on our homework, I'm going to actually give you a paper that has the grids drawn. Like, you're going to get paper that has the grids on it. Okay? So we're going to be able to break it down into more individual and specific points here. So if this makes sense to you, then you're on your way to understanding what we're going to do next. But to do that, we need the dry erase board. So why don't we say, let's go this side, you can get a board and get a marker and then grab one of the tissues there as an eraser. As soon as they're done, you guys, this side can go. No, you can put the notes and stuff away now. The only thing you need is the board. Equation here. 2x plus 6 equals 16, we'll say. Now, if you look at that and you think, I have a way that I would probably attack this problem right now, that's good. But I'm going to ask you to hold off on that because we are going to use these bar diagrams today to try to figure these out. So 2x plus 6 equals 16. Here's what we're going to do that's a little bit different, guys. Rather than just randomly creating a bar, let's create a bar that has a length of 16 blocks. Let's use these grid lines in our favor. So I think yours is 20 blocks wide, so use that. Create one that's 16. What's that? I'm doing 16 blocks. Yeah, so this way we know the value of every single one of these is just 1. And this is going to help us for when we're trying to like cancel out different things, okay? So just make me a 16 block row. And then while you're at it, you can go right up above it and just create another row that's the exact same length. Because we know that the bottom row is 16, and we know from the equation that 2x plus 6 is equal to that 16. So the top row represents 2x plus 6, the bottom row represents 16. And here's what we're going to do. We're going to work backwards a little bit. On this top row, I know that I have 2x plus 6 is 16. Now, we're not going to divide it up exactly like we did with when we didn't have any grids, because I know 1, 2, 3, 4, 5. I know I have 6 singles right here. The rest of this bar right here, from here back, is equal to 2x. Just try to follow me on this first one or two, just so you get the idea of it. because this is going to be exactly like the questions you're going to do tonight. So I have this equal to that. Well, mathematically, those of you that said, well, I would do it a certain way, what would you do first if I was asking you to find the value of x here? What have you been doing first to solve this? Any ideas? Go ahead, Riley. Not yet. We don't want to divide by 2 because we're not saying, we're not going to split this in half yet. Yes, the first thing a lot of us have figured out is that we're going to remove 6 from 16. Now, if I do this physically, I could take away these 6, which means now this bar is not 16 in length, it's 10. So I have, what I have left here is I have 2x, and we're saying 2x equals 10. So what would x have to equal then? It's this part here is equivalent to 2x. The bottom row is equivalent to 10. That means I want to split this bottom row up into 2 equal parts. So x must equal what? 5. Okay, so 16 minus 6 is 10. And a lot of you said, well, I divide 10 by 2. And that's how I would attain my 5. You didn't see that catch there, Marco. Looked like Odell, didn't it? With the hands like Odell, I just snagged that thing. I don't feel like I got the credit that I deserve on that. All right. All right, let's try another one. Thank you. All right, here we go. Let's go 8x plus 2 equals 18. So you have 20. Just work backwards. Yep. And do the same thing. Create a double row of 18. Try to create straight rows like I can't. Okay. So the bottom, like before, the bottom is equivalent to 18. The top will be equivalent to 8x plus 2. Bless you. So on top, we have 2 singles because it's 8x plus this 2 single. That means the rest of this top row here, so from here to here, is equal to 8x. So go ahead and try to figure out what x has to equal. The bar? Okay. Yeah. You don't have to. You can. I just want you to use a form of the bar. So if you can adapt it in a way that you like, then do it. So what is the, let's talk about, before we get the value of x, what were the steps that you're using here to find the value of x? Like, did you erase something on your board? Did you do something mathematically? Can we describe it? Go ahead, Emma. Okay, so you took away like 2 blocks like this. Yeah, because she gets to this point, then you know 8x is equivalent to 16 blocks. And then this is our one. We're breaking this bottom row into 8 equal parts. So that's what she's saying. Divide 16 by 8 to get 2. Like, so you put like a 16 down here? Yeah. Uh-huh. Yep. Good. All right. Why don't we try one where you create the equation? So this last example we're going to do, you try to come up with an equation. Try to keep it in this format. Yeah, don't do like x plus 1 equals 2. That would be a one-step equation. Let's create a two-step equation. Build it, like write your equation, do your diagram for it, solve it, do the whole thing on your board. Give it a shot. Leave that up there so you have something to look off of. Don't use my equation. Just make up your own two-step equation, kind of like that, but then draw the bar and solve it for this. Okay, equals something. Equals what? So that, and then you can solve it. Okay. So then you would solve it to tell me what x would have to equal that. Well, that could technically be a one-step equation because all I really have to do is take away 2 here. So change that coefficient. I know it makes your problem a little more difficult, but change that coefficient there. Since you're creating the equation, it might be beneficial if you already knew the value of x. Like if you said, okay, I want x to be equal to 2, and then write your equation based on this. It's kind of like a backwards approach to it, but that's how I do it. When I make up an equation, I already know the value of x that I want it to be, and I just work backwards. Well, if you're going to try to model that on the diagram, you don't have 42, right? You only have 20 wide. Well, you could do like, remember how we were doing before? You could just draw like a blank one and split it up into 14 parts, right? Remember how we were doing these ones right here? Or you could change that. Yeah, you could do that way. So what I'll do, because I won't have time to show everybody's on here, is I'll go around, just check some of these. If you have an equation with your value solved, then I'll just verify that it looks good, that it works. You get that's good now. X is 2, yeah, that's good. Yeah, that's good. That works. That's good. Let's see, x is 3. Yeah, that's right, Ben. Uh-huh. So 4, yep. That's better, yep. So 2 equals 12. So you took away 2, right? So now 6x equals how many? Oh, I see why. You're going to get a decimal. Yeah. So what I would do, maybe bump this up, make it 2 more, make it a 14. And then it's going to work out a little easier, yeah. Just punch a hole and go on that one. Did you get one?
But that ended up being really easy. I didn't realize that.
Well, yeah, when you modified it to fit what you wanted, then it worked. Oh, that's good. Yeah, because some of you might have been finding out that you're solving it and you're getting decimals, right? And that's possible. I know it's not optimal, but it's possible. That's it. That's why I always start with the value that I want first. Double line.